Happy day, students. In our last class, we saw the effect of the glass slab where it is introduced in front of one of the slits. Okay, we calculated optical path also, and we found out what is the path difference it is developing at the position of central maximum. Okay, today we are going to see further effects. See that what we did in last class is, suppose this is the one slit and this is other slit. Here is the screen, and here we introduce one glass slab. Its coefficient of refractive index is mu and its thickness is p. So because of the introduction of this at this point, we were not getting the central maximum. What is the reason? The reason is because the path difference at point P is not zero. And what is the path difference? We are saying it's not zero. Delta x at point P is not zero. Okay. Geometrically, if you see, it appears that S1P is actually equal to S2P. But what is happening here? The ray is passing through the slab, because of which the equivalent path is traveling is more than the path traveled by this. So how to write S1P actually? S1P actually is written as S1P plus mu minus 1 into T. Okay, it is written like S1P plus mu minus 1 into T. If suppose delta x I have to write at point P, it is S1P plus mu minus 1 into T minus S. Okay, did you understand that? This is the path difference. Now, we said that because here path difference is not zero, central maxima is not here. Then where will be central maxima? Central maxima will shift upwards. Why upwards? Why not downwards? Central maxima is shifting upwards. Reason being, when the ray is passing through the slab, it has to travel extra as compared to the ray traveling in air. It has to travel extra. So, to come to point P also, this one is traveling more. So, where we have to choose the point? We have to choose the point in such a way so that this also travels equal to this. How can we do so? When we go to the farther point of this and nearer point to this. That means nearer to S1 and farther to S2. Where is possible? Up. So, here we assume that our central maxima is, and here we assume that our delta x is 0. Right? And then in the last class we found this y value also. Now y value, if I go back and check out again double slit experiment and what we found, it was actually delta x capital D by small d. Delta x capital D by small d. That was the formula for y maximum. In that one we used to say this is central maxima position. But here central maxima is not there. Okay? But this is center of the screen now. The center of the screen. Okay, so this is the function, this is the formula. So what is the path difference we are having here? This is mu minus 1 into T, D by D. So this will be the position of central maxima for us. Okay, from center of the screen. Or you can say this is the position of center of the screen from central maxima. This is the formula that we derived over last class. Okay, now what we want? We want to know, since we are saying that central maxima position in this one has moved, has shifted, central maxima has shifted upwards. So does it mean that the entire interference pattern has shifted? What is interference pattern? Normally interference pattern means is, if this is central maxima, here is first maxima, here is second maxima, and same way below also first maximum and second maximum. Okay, now if this central maxima has gone to this position, does it mean that this first maxima and second maxima also has gone up? And this second maxima and first maxima has gone further up? Does it mean that? Answer is yes. Yes, the entire pattern has gone upwards. So now what we are trying to find? We are trying to find that earlier here was central maxima. It has gone up. But how many maximas have passed through point P? for how many fringes have passed through the position of central maxima, that we have to find. Okay, now how to find it? Now suppose this is central maxima and this is second maxima. Let's assume, or third maxima. Okay, so between central maximum and third maximum, what is the gap? Shall I say that 3 beta? That means 3 fringes. We can say that. And if it is 3 fringes over here, then here delta x will be equal to what? 3 lambda, because delta x is 0 here, central maximum. So here delta x is 3 lambda. Correct or not? Exactly same thing we are going to apply. Now see, because of the introduction of this slit, this slab over here path difference is mu minus 1 into t. Okay, here path difference is mu minus 1 into t. Now, this delta x, normally if you want to find out which maxima it is, this delta x we write as n lambda. Okay, delta x is written as n lambda. So here also I am going to do like that only. N lambda equal to mu minus 1 into t. So n equal to mu minus 1 into t by lambda. Okay, now what is this n? N is number of fringes. Whatever the number of fringes are, same will be the number of maxima also. Okay, why I am not saying this is number of maxima? Because what happens, sometimes this n comes in fractions. Suppose it's coming 5.3. What does that mean? 5 maximas have crossed upwards. Perfect. So what does that mean? Let's try and check it over here. If this is central part of the screen and we are saying n is 5.3, so that means here will be 5th maximum and here will be 6th maximum. When you say 5.3, that means this is 0.3 times of the fringe, because I told you that if delta x equal to 3 lambda, that means third fringe. 3 beta will be the gap between maxima and that point, as I told you here already. Okay, I wrote this is 3 beta. Okay, if this is third maxima over here. So here will be 3 lambda as the path difference, but how many fringes? 3 beta. Same way here what is coming? 5.3. So that means 5 maximas have crossed upwards, but there is a 0.3 portion. 0.3 portion of what? 0.3 portion of fringe. 0.3 of a beta. And below here, what is this? The 0.7 beta. Because between 5th and 6th maxima, how much is the gap? Beta. So this is 0.3 beta, this is 0.7. So both are separate questions. They can ask you this, how many number of maximas have crossed the central maxima? Or maybe if this slab or this glass slab is here, then central maxima will go down. They will ask you that how many maximas have gone down. If this comes in fraction, they can ask you from the central part of the screen above, where is first maxima, and below, where is first maxima. So above first maxima will be 5th maximum for this one, and below first maximum is 6th maximum. So we can say that it is at 0.3 beta, and this one is at 0.7 beta. Okay, so with this way, 2 questions we can solve. Let's see further, what else can we do with this slab. So see then, if I am going to introduce 2 slabs, one for the upper slit and one for the lower slit. These are the 2 sources again. Here is one slab and here is the other one, and here is the screen. Let's say coefficient of refractive index is mu1 and thickness is p1, and here is mu2 and p. Okay, the first question is, what is the path difference at center of the screen? That is the first question. And mu1 and mu2 are not equal, p1 and p2 are not equal. More we can say is, suppose I take mu1 is greater than mu2 and p1 is also greater than mu2. Then what is going to be the path difference at point O? So delta x. First I am writing this one, h1O plus mu1 minus 1 into T1. Okay, geometrical path S1O plus, because of going in this one, how much extra the ray has to move? U1 minus 1 into T1 minus this one, S2O plus mu2 minus 1 into T. What's going to come then? S1O minus S2O plus mu1 minus 1 into T1 minus mu2 minus 1 into T. Now we know that geometrically S1O and S2O are equal. So this is 0. So what we are getting here, this is mu1 T1 minus mu2 T2 plus T2 minus T1. This will be the delta X echo. Okay. Then what we can say is, suppose someone is asking that how many maximas have crossed. Now in this case, where will be the maxima first of all? Above or below? Is mu1 T1 bigger than or mu2 T2 bigger? mu1 T1. So that means in this one it will travel more far. So that's why the maxima will go upwards. Okay. So now the second question comes out, how many maximas have crossed the central part of the screen? Again, what do you do here? N lambda mu1 T1 minus mu2 T2 plus T2 minus T1. So n equal to mu1 T1 minus mu2 T2 plus T2 minus T1 by lambda. Okay. Normally in the questions that you are going to solve, this T1 and T2 will come same. That means this term will become 0. T2 minus T1 will not be there. So path difference will be mu1 T1 minus mu2 T2. Okay, that will be the path difference. But in this particular case, I have taken T1 and T2 different. Alright, so now, if suppose this is the case, and again I ask you, where is the central maxima? We have already decided it is above the center part. So if this is Y, then how we are going to find it? Again, we will use that same formula that we use normally, delta X, capital D by D. This is the distance of any maxima that you are finding from central maximum. That formula we are going to use. Okay, so delta X value we already have calculated here. I am going to put in this one, so we will be getting Y value. Is it okay? So this is the position of central maxima from center of the screen. Okay. Then further what we can do? Let us take inclined incidence. Okay. Oblique incidence. So suppose it's going like this. Okay, these are two slits, S1 and S2. This is oblique incidence that we have studied before. Now in this case, is at point O central maximum? Answer is again no. Why? Why no again? Because S1 and S2 are not in same phase. Because the light is not traveling same distance to each pole. And S2 is traveling less distance. Right? So here path difference is there. How to find that? Drop a perpendicular. Okay, this is D. Let's say this is alpha. We can write this is D sin alpha. Okay, now here I am not getting central maximum. Suppose the question is asking you, where shall we place the slab so that central maxima can form at O only? Okay, where shall we place the slab so that the central maxima comes back? But first of all, because of oblique incidence, where is central maximum? Say up. Why up? Because you can see that this one is traveling more to reach over here. So what we have to do, post this sources, we have to make this one to travel more. So this can travel more only when you go up. Okay. So already central maxima is forming up. Now we want to bring it back. Where shall we use the slab? Here. Let's say mu and T. Okay, now we want the central maximum to form here. That means delta X we want at 0. Okay. Now, how to bring it 0? What shall we do? That means path difference on this side. If it is equal to path difference on this side, we can say that we can bring delta x 0. Let's see. At this point I say here, this is A. So total path difference I am writing, just take that. Delta x A S1 plus S1 O minus A S2 plus S2O plus mu minus 1 into T. This is the path. Again further we write AS1 minus AS2 plus S1O minus S2O minus mu minus 1 into T. Now we know that S1O and S2O geometrically they are equal. So this is cancelled. AS1 minus AS2. AS1 minus AS2 is actually equal to D sin of. This is D sin of. Minus mu minus 1. So delta x is 0 we are saying because of the central maximum. What you will be getting then? D sin alpha equal to mu minus 1. Now in this case what they can ask us? They can ask us anything. They can give mu and t and they can ask you alpha. Or they can give you alpha value, give you mu value and they can ask you t. Or they can ask you mu after giving the value. So this is how we can do it. Okay. Now in this one also, let's suppose we don't want here central maximum. We want central maximum somewhere other place or some other position we want to have the question. We can use the same formula and we can do that. Okay. So this is how we will be doing oblique incidence question. Another question I'll ask now. Let's solve one question and see how can we use the method that we have learned so far. So let's see. The split over here, this is another split, that's S1 and S2. Here is a screen, and let's assume I am taking the split at this point. Mu and T is over here, and suppose the central part of the screen, I am not getting maxima obviously, but I am getting intensity which is 2I. Intensity of this source is I, intensity of this source is also I, but I am getting what intensity over here? 2I. Okay. What the question is asking? Question is asking find T. All other data we will be taking as it is, like capital T is this one, small d is this, and d is very large as compared to d, and small d is very large as compared to lambda. All these rules or regulations that we have learned so far we will be using for that. Here is 2I. You can take I also. Suppose I change the question. Take it as I. Okay. You want to have intensity here as I. Now what we know, because of interference, the resultant intensity at any point is IR is equal to maximum intensity. What is maximum intensity? 4I cos square pi by 2 or delta pi by 2. Resultant intensity you have written I over here. So this is 4I cos square delta pi by 2. I gets cancelled. This is 1 by 4 equal to cos square delta pi by 2. Square root 1 by 2 equal to cos delta pi by 2. Okay. Cos inverse 1 by 2. First of all, this is cos square. So this should come as plus minus. Okay. Now, this is I. It can be asked from you that maybe the above one here is first maxima or second maxima or maybe any maximum. Suppose I take it as first maximum. So where is central maximum? Somewhere. Central maximum, first maximum, and let's assume here I am going to take second minimum. Okay. So when you talk about central maximum, what is the phase difference here? 0. First maximum phase difference 2 pi. Second minimum phase difference 3 pi. So that means this point over here is between 2 pi and 3 pi. Normally, what will be the value of 1 by 2 will be associated with? 5 by 3. Sorry, 5 by 6. Okay, and you can see that it's more than 2 pi. So I'll add 2 pi plus 5 by 6. That will come 13 pi by 6 equal to delta pi by 2. Okay, so 13 pi by 6 equal to delta pi by 2. This is 3. So delta pi I am getting as 13 pi by 3. And delta pi we can write as 2 pi by lambda into delta x. And this pi gets cancelled. What is delta x value? Delta x value we are getting as 13 lambda by 6. 13 lambda by 6 is delta x. And who has produced delta x over here? It's because of this glass slab. Because otherwise, there is no path difference over here. Because of this only the path difference has come. How much? Mu minus 1 into t. So since t is asked from us, t value is 13 lambda by 6 into mu minus 1. Okay, so depending on the position given to us, we will be choosing this value. Because it was between 2 pi and 3 pi, I added 2 pi into 5 by 6. If suppose some other value is given, you can use some other values. Okay, so this way we will be finding out what actually is going to be the pi value over here, depending on its position. Okay, so this way the question can be asked on the glass slab when it is placed in the path of the light in front of the source. Okay, oblique incidence also we saw, and these glass slabs also we saw. Okay, so that's all for now.